What's up, guys? Wanted to come and do a little recap with you from over going over the little assessment thing that we did earlier today. Some are doing quite well, but there's still some that are just not quite getting what I'm wanting out of them, what the standards wanting out of them. So what I want to do is take this opportunity to help you understand what is the standard wanting and what should you be able to do here. So I'm going to turn the screen around real quick and we're going to review it. All right, so today you had an equation, f of x equals x squared plus 8x plus 13. And I wanted you to do a few things. Let me turn this way. For one, I wanted you to be able to find the axis of symmetry. So up on my board, if you'll recall, I have these formulas. And while I'm at it, I'll just go ahead and put this one up here as well. Okay, so I wanted you to find the axis of symmetry. So remember A, B, and C values. I just plug them up in here. So I'm saying x equals negative, and then I put the 8 over the 2 times 1, which is negative 8 over 2, which is negative 4. So what that means is if I go here and I go back 1, 2, 3, 4, and I draw a vertical line, that's my axis of symmetry. And so the standard A.APR.3 here, and I'm reading off my board here, here's what it says. Identify zeros of polynomials and use them to draw a rough sketch of the function. So now, I've not gone and found the zeros yet, but one thing I do want to be able to find is find my vertex. If I know where my vertex is, this makes it easier as far as the sketching part is concerned. So it's good to do this. So to find I know the vertex lies somewhere on this line. Well, the question is where, right? We know it's somewhere on here. But what we're going to do is we're going to take that x value and we're going to plug it back into our function. So I'm going to say f of negative 4 is negative 4 squared plus 8 times negative 4 plus 13. It's going to be 16 minus 32 plus 13. It's negative 16 plus 13, which is going to be negative 3. So my vertex is going to be negative 4, negative 3. So it's going to be sitting right here. So we can kind of get an idea looking right here. So that right there is a positive. So that means it's going to be smiling. So now here's what we're going to do. We're going to take our quadratic formula. Remember that this thing right here, it is designed to find your roots. That is its sole purpose in life, is to find the roots of quadratics. So I'm going to say, all right, I'm going to do some. I know I tell you I'm not doing it in pen, but I'm going to do it in pen. Because I'm the teacher. I can do what I want. So when I plug my values in, I'm going to have negative, then I got 8 in there. Oh, small. I was trying to get ahead of myself there. All over 2 times 1. Oh, you probably couldn't see that very well, could you? So there it is. So I'm going to have negative 8 plus and minus. Let's see, 64. 8 squared 64. 4 times 13 is 52. So that's going to be a negative 52 all over 2. So that's a negative 8 plus and minus. It's going to be the square root of 12 over 2. So this right here can break, the square root of 12 can break down to 2 radical 3. That's 4 times 3. Take the square root of 4 is 2. So 2 radical 3 Now, I'll go ahead and tell you this. Now, you could reduce these the 2/2 and 8/2 down, but listen, your calculator is not going to distinguish that. It's going to do it for you. So really, at this point, you can make two expressions here. So you got x equals that, and x equals -8 minus 2 radical 3 over 2. So what I'm going to do is I'm going to use my calculator and I'm going to plug those values in. No sense in making life harder on myself. So remember on the assessment, I asked you to show your work. Here's what showing your work looks like, guys. Now, when you get down to something like this, by all means, jump to this thing. Use that calculator. It's a tool for these sorts of things. So, we got 2 times the square root of 3. I'm going to store that. And 1 there. So, I got -8 plus the 2 radical 3, because I got that. I'm going to divide that by 2. I got a negative 3.13. And then I'm going to come back here and I want to say, well, wait, let me do that one more time. Hang on. I think I made a boo-boo. Times 2. Okay, store that in 1. That divided by 2. Oops. Guys, I made a mistake. When I typed that in, I mistyped. So, my bad. We'll make that -2.27. I was thinking that wasn't sitting right with me. So, -8 minus, recall 1. Is that divided by 2? Okay, so, Lordy. All right, so here are my 2 roots. Now, what I wanted you to do is you go up here and you go find -2.27. So, 1, 2, -2.27, about right there. Close enough for government work. And then -5.73. 1, 2, 5.73. That's about 3/4 of the way there. So, about right there. And what I wanted you to do, guys, is I wanted you to take a couple of points. So, like, I'm going to take, what's this? -5, -4, -3. So, let's tell you what, let's go. And let's plug them into our function. So, I got f of -5, that's going to be -5 squared plus 8 times -5 plus 13. So we got 25 minus 40 plus 13. Be a -2. So at -5, -2, there's a point. So then f -4. Again, this should look very familiar to you, right? That's going to give me a -3. See, it's right there. Then I'm going to do -3. And it's -2 again. Which makes sense because it's symmetrical. So now you could keep carrying this thing on out if you wanted to. I mean, it's up to you, but really, I've got enough points here to kind of get a good idea of what this thing is doing. So guys, this right here is what I was expecting to see. This this is what I wanted to see. Is I wanted to see that you knew how to take a function, find the axis of symmetry, then use axis of symmetry to find the vertex, then take the quadratic formula, find the roots, plot them, then pick some points there to kind of help fill in the gaps and try to get you a nice curve. Because I'm going to show you right over here. Right here, guys. Identify zeros of polynomials and use them to draw a rough sketch of the function. This is our main standard that we're trying to learn. So, I hope that helps a little bit. Remember, guys, the stuff that I teach you is not just simply to waste time and to say, well, I've just got through the course of study, so that's it. But no, the stuff you need to retain, because guys, once we get into polynomials, a lot of these concepts are going to come back up. We'll be sketching polynomials. Remember, polynomials are a very big and broad term. A polynomial can be a quadratic, like what we're using right now. It can also be a cubic, a quartic, quintic. It can go on to infinity, really. So there's the concepts that I'm teaching here with the quadratic. The quadratic is a good, very easy function to work with to kind of help set the tone. But you really, really need to understand these concepts before you are get into this polynomial. So try not to ramble here, but you really need to get a handle on what I'm trying to teach you here. So I hope that helps. Go online, like to the Google Classroom. I've got quadratic functions, practice like finding roots and all that. Pick some of those out and try this. If you want to do some and then bring them to school and let me look at them and see if you're on the right track or not, by all means do that. I'd be happy to do that. I want you to get this. I want you to do well. So with that, I'm going to figure out how. I've never gone live on YouTube before, so I got to figure out how to turn this off. So yeah, happy studying. Y'all have a great day. Let's see. How does that? Let's see. Cancel. Let's see. Do share. Nope, that's not it. Did I turn it off like that?